Hi there, Wildcats. Welcome back to your geometry class. Today I'm going to discuss and model how are you going to classify rigid motion, and we are going to dive into a deeper understanding on composition of transformation. And to master that, we need to have skills on doing reflection, rotation, and translation. Right? So the notation for composition, okay, is an open circle. Looks like that. So let us say you have a notation like um, translation 1,5. This is, you read this one, composed of, let's say, reflection along x-axis. Okay, so you have to read this one as a translation 1 up, 5 down after, okay, a reflection along x-axis. So what are you going to try to do is, if you're given an image, so you start with reflecting it first before translating it. So reflect and then translate. So you will be, the process is that from right going to left. All right, so in this video also we'll be doing a glide reflection and then composition of rigid motion, or composition of transformation, sorry. All right, so again, you have to do this first. Do first, and then, sorry for my penmanship there, and then you do second. This is the second thing you have to do. So it's like from right to left. Okay, so let's proceed with our first example. Classification of rigid motion. One is, of course, this will be composition. If you are looking at the image here, okay, this is our pre-image. So I'll just map this one. This is our pre-image. So we are analyzing the movement, okay, the transformation of the image. Okay, so this is now your image after several transformation. We do not know how many transformation have been through of this image. So is there a rigid motion that maps your triangle ABC to triangle A prime, B prime, C prime? So if you are looking at the image and analyzing it, it's difficult to see the transformation. So when you check the your translation, some of the points can be translated by 4, -5, but your A is not at 4, -5. So translation is not applicable to that. When you do check on reflection, there is no line of reflection that produces the image. So the rigid motion is not a reflection. Okay, but if we are going to check whether it is a rotation, okay, so we are now applying our knowledge or our skills on translation, reflection, and rotation, because this is a composition of transformation. When you check your when we check rotation here, the orientation of the triangle is not preserved. The rigid motion is not rotation. Okay, so what should we do here? Now, again, it's a composition. So what are we going to do is, because your ABC has a clockwise orientation, okay, your ABC has a clockwise orientation, and your triangle A prime, B prime, and C prime has a counterclockwise orientation. So you're just looking at that. Maybe I can do I'll reflect it first in a so I have to create my own line of reflection, and then I have to reflect that. So let us say my line of reflection would be on this area here. So just create a line here. Line of reflection may be on -1, let's say this is my line of reflection. So I'm going to reflect every single point that I have there. Say that's 1, 2, 1, and 2. This is my B. Okay. This is B reflection. Maybe I'll just double prime that. And then C, it's 1, 2. So 1 and 2. You see, there is C double prime. And then 1, 2, 3, 4. Then 4. 1, 2, 3, 4. So this is my A double prime. So if I'm going to connect these points here, you will see how the composition looks like. So I'll just use blue color here to connect this. Now this is the image of the first transformation that we have. So we did reflection. We did reflection, and then from there, okay. So from there, okay. Remember, the first thing that we had to do is we reflect that along y is equal to, or x. Sorry about that. Reflect that along x is equal to -1. That's the first movement that we did. And then, let's see. So the orientation, so comparing the blue and the red, so rotation is not done here. So compare that, and reflection also is not possible. So translation, so it translate from, that's 1, 2, 3, 4, 5. So let's see, 5 down. And then let's see C, 1, 2, 3, 4, 5. Also 1, 2, 3, 4, 5. It's 5 down, so it's -5. Does it move from left to right? No. So there is no movement from left to right, so it will be 0. So meaning it translate from your x would be 0, and then it's -5. So we can now write the rule for the rigid motion on composition here would be, what we did first is we reflect that. Okay, so we do reflection along the line of reflection is equal to x is equal to -1, composed of, we translate the image from, okay, 0 going down, -5. So we have now the rule for this example. So looking at our rule here, a decomposition of the reflection followed by a translation in a direction parallel to the line of reflection is a rigid motion. We call this one as glide reflection. Okay, so we reflect that and then we translate it. Which is the translation? Look, it's parallel to the again parallel to the line of reflection. All right, next problem here. We have, what is the glide reflection that maps triangle JKL to triangle J double prime, K double prime, and L double prime? So we have to take a look at how it looks like when we did the glide reflection. So first is we have to determine the translation. Determine the translation by vertical align J double prime with J, and then L double prime with L. Okay, J double prime and J double prime here. So L double prime and then K double prime and K. So it is 5 units horizontally and 0 units vertically. Okay, so I'll repeat, 5 units horizontally and 0 units, it's horizontally, 0 units vertically. Okay, so that is for your when we map the translation. Second is we have to determine the line of reflection. So what is the line of reflection? The line of reflection is line of reflection is y is equal to +1. All right, so if you map, the first thing that we have to do, it says there 5 horizontally, so 5. So j will be 1, 2, 3, 4, 5. So let's say this is your j prime. Okay, and then we also have L. So 1, 2, 3, 4, 5. So L is 1, 1, 2, 3, 4, 5 also. This is L prime. And then K is 5, 1, 2, 3, 4, 5. So this is your K prime. Okay, so if I'm going to connect those, to make my triangle look like that. Okay, so we are analyzing, what we are doing here is we are analyzing how come that my block triangle there, triangle JKL, okay, becomes the triangle J double prime, L double prime, K double prime. So that's what we are mapping there. We are analyzing it. So what I did, it's like you take a look at the movement, five units horizontally and 0 vertically. Make sure that all the movements will equal to all of every single point that they have there. Meaning if one point moves 5 units, then all of the point must be moving 5 units, right? So this is my the first thing that you have from black to blue. Okay, that's what we are doing now. So it's reflecting from y is equal to 1. So what I'm going to do here is I'm going to map my y is equal to 1. It's here. This is the line of reflection. Or maybe I can change the color of that so that it will be a lot easier to see. Maybe yeah, green color. Y is equal to 1. It's here. Okay, so that is the reflection. So first thing that they have to do is they reflect. Okay, they reflect and then they move 5 units. So you see here, your block here, JKL, triangle JKL, reflect along y is equal to 1. That's why we have the blue image. Okay, and then the blue image, it's translation right after. Okay, so what's the first thing they have to do? So they reflect along y is equal to +1, composed of, and then it translates to the right. So translation, and the movement is just only horizontally. Okay, it's horizontally, meaning it's your the change is on the x. Okay, so it's 5, 0. So this is now the rule. Okay, translation 5, 0 after reflecting the image, where the line of reflection is y is equal to 1. All right, next example we have here, we try to do the composition. Okay, so the first thing that I have to do here is I'm going to maybe I'll just use black here. I'm going to locate my point A, B, and C. So my A is 6, -1, 6, -1. It's here. This is my A. And my B is 5, -7. This is B. And my C would be 3, -4. Is that -4 there? Yes, it's C. And then I'm going to connect this one, of course, using my pen here. So I'm going to connect. Sorry about that. It should not be a line. And this one is C. Thank you for your patience there. So C, and it should be a segment. Okay, so this is my triangle ABC. Okay, and the rule says we have to do the translation first. -3, it goes down 3 times, and then it moves to the left, or it goes to the right first. Okay, this is your x, sorry. This is horizontally and this is vertically. So -3. So maybe I'll just use blue here. So -3, it goes to the left. So 1, 2, that's 1, see first, 1, 2, 3, and then 5 times 1, 2, 3, 4, 5. This is my C prime. Okay, because that's the first movement. Then A, it's 3. 1, 2, 3, 1, 2, 3, 4, 5. This is my A prime. My B prime, it's 1, 2, 3, 1, 2, 3, 4, 5. This is my B prime. Okay, so kindly check the movement, guys. So, alright, so I'm going to connect this string. This is my A prime, B prime, and C prime. Okay, and then after that, that blue here, so that blue is, we are going to, of course, I'll be using maybe red. For my double prime, it says there, the reflection is at y-axis. So reflection is at y-axis. So this is my line of reflection here. My line of reflection is at y-axis. This is the line of reflection, which is the blue color. Okay, so I'm going to use a red one here. Reflection, of course, C, it's the same. So my C double prime is equal to C prime. So this is C double prime. So I'll reflect 1, 2, 1, 2. This is my B prime. And A prime, it's 1, 2, 3, 1, 2, 3. So this is now my A. A double prime. And then I'll just connect them. All right, so we are connecting this with a segment. So sorry about that. I'm going to use red. So you can see it's here, there, and there you go. So we have now your reflection of, again, it's the red one, it's double prime here, C double prime and B double prime. So we have now, we translated -3 and 5. So 3 to the left and 5 up. And then we reflected along the line of reflection, which is y is equal to, the line of reflection is y-axis. All right, so let's do the second one. First is we have to map your A, B, and C. Okay, so I'm going to map this one. A is 1, 8, 1, 8. This is A. My B is at 4, 7, 4, 4, 7. This is B. And my C is at 1, 3. Okay. So I'm going to connect this using black color. There you go. I have my triangle ABC. Next is what are we going to do is, first is we have to rotate this one 90 degrees. Okay, so rotation for 90 degrees, I'll repeat, rotation along the origin 90 degrees is we have to follow the rule that we have. that we discussed before, that if it is 90, it will become, your x will become, you flip the position and it will become negative yx. So instead of xy, it will become yx, and the y will be the opposite. So your a prime here after rotation will be a prime, you flip them 8 and 1, and then your y get the opposite. Your b prime will be 7 4 because I flip it and then get the opposite of the positive 7. And then my b prime would be c prime, sorry, it would be 3 1, and then get the opposite of positive 3, which is negative 3. And then you just map that, so negative 8 1. Okay, negative 8 1, that's my a prime. And then we have negative 7 4. This is my b prime. And my c prime would be negative 3 1. Negative 3 1. This is my c prime. So I can, again, I could connect them using the blue. So this is after rotation. Okay, we have now your triangle A prime, B prime, and C prime with the coordinates there. And then after that is, I'm going to use red for my double prime. It says there, it reflects along x-axis. Okay, so the line of reflection here is, we have your, again, the line of reflection, it says there x-axis, it's this one. So maybe I'll just use red here. Line of reflection is along x-axis. This is your x-axis here. So this will be your line of reflection. Now let's map that. Reflection, it's 1 and 1. This is my a double prime here. A double prime. My b is at 4, so I'll go negative 4 here. So this is b double prime, and c is 1, so I got 1 here. This is c double prime, and then ready to connect those points to make your triangle. Alright, so I'll just use this solid here, and once you connect them, you're done with the composition. Okay, so that is the composition and classification of rigid motion, right? So again, a composition is composed of two or more transformation. It can be reflection and can be reflection, translation, and rotation. Thank you guys, and we'll see you next time. Bye bye.